Hi there. In this video, I'm going to show you how to solve an equation that has radical symbols inside. Okay, it's not as hard as it may at first appear, but pay attention and let's work through this first example together. Okay, so the general idea of solving an equation with a radical, well, first is to solve for the variable, right? We want to solve for x, but notice that the expression x minus 4 is underneath the radical, okay? And so the only way, let me see, what's the right word? The only way you can cancel that radical out or to get rid of the radical is if this is a perfect square underneath, or if it's a radical squared, okay? So before I solve this problem, let me see if I can show you an example. So if I gave you the square root of 3, okay, and I asked you to square that, so I would want you to draw parentheses around it and draw a 2 as an exponent, okay? Well, what does that mean? That really means radical 3 times radical 3, which is the square root of 9, okay? But what does the square root of 9 simplify to? The square root of 9 simplifies to 3. Okay, so now I want your eyes to go back to the very beginning. I want you to look at this number right here underneath the radical. Okay, we squared radical 3. We went through all of this, and we ended up just with 3. Okay, so when you square a radical, the answer is always just the number that was underneath the radical. So in a way, the exponent 2 cancels with the radical symbol. Okay, so I hope that will kind of help as we work through these problems together. Okay. So using that little example I just showed you with squaring radical 3, we're going to do the same thing up here. The only other thing I really need to tell you is that before we square the radical symbol has to be on the side of the equal sign all by itself. This example is already set up that way for you. There is no other number either before the radical symbol or after the radical symbol. And so we can go ahead and get started. So really just like any other equation, what we do to one side, we're going to have to do to the other side. I want you to draw parentheses around that entire radical expression. And then you're also going to have to square the 3. All right. Now using that little example I just showed you with squaring radical 3, I'm going to go ahead and just say this exponent 2 is going to cancel out this radical. So I'm going to kind of do a little squiggly, and you're left with x minus 4 equals 9. Because 3 squared, we can do that math. That really is 9. Okay, look how easy this is. Next, I just want you to solve for x. We're going to add 4 to both sides, and x equals 13. Okay, let's try another example together. Now I want you to notice that this example, there is another number next to the radical. We have the y minus 8, and it's tucked in, really nicely under the radical, but then there's this plus 5 that doesn't really belong. And so before you can square both sides, this radical expression has to be alone. Okay, so the first thing I need you to do is just simply subtract that 5 over to the other side. And I want you to rewrite the problem so we have square root of y minus 8 equals 2. Okay, now you're ready to square both sides. I'm going to do that in blue. So we're going to put parentheses squared, parentheses squared. Okay, and again, when you square a radical symbol, They cancel each other out. You're left with y minus 8 equals 4. Okay, I can already feel that you're smiling because it's such an easy problem now. Plus 8 on both sides, and y equals 12. Okay, take a look at this problem. Again, with this example, there is a number that's not underneath the radical and it's on the same side. This time the 10 is attached through multiplication, and so to move the 10 to the other side, you need to divide both sides by 10. So let's do that first. Do that. That leaves you, and I do want you to rewrite the problem, to square root of 9x equals 6. Okay, now that the radical is by itself, I want you to square both sides. I'll do that in blue. Okay. Okay, when you square a radical, those two cancel each other. So you're left with 9x equals 6 squared is 36. Now we're going to solve for x. Divide both sides by 9. And x equals 4. Okay, let's look at one more problem again together. Now in this example, it's a little bit different because we have two radical expressions and they happen to both be on the same side. But I still want you to stick with this idea that a radical expression has to be alone. That means it can't even share a side with another radical expression. And so I want you to take this second radical expression, the square root of x, and move it over to the other side through addition. So it would look something like this. It would be 2x minus 9, or the square root of 2x minus 9. And if you add radical x over, it equals, okay? Okay, so even though because it's two radicals, they're on separate sides, so you can now square both sides, and there's not any other number besides the radical expression. Okay. On both sides of the equation, the exponent 2 is going to cancel the radical. And so you have 2x minus 9 equals x. And then from here, because I already have the negative 9 over here, I'll go ahead and just pull this, the 2 to the other side. That leaves with negative 9 equals x. Take away 2x is negative x. Now we can't leave our answer as a negative x equals something, so you really need to just divide here by a negative 1 to get a final answer of x equals positive 9. Okay, I want you to pause this video and try a few examples on your own.